These 150 cubes are all rotating at different speeds and some of them in different directions. They surge in their rotation as well, and sometimes reverse. They all shrink to a small size and then grow, but they also pulsate at different speeds. To keyframe that would be daunting. The animation node plugin for Blender can handle all of that. Zach Hickson has some excellent beginning tutorials. You can see a link to the first one above. What I'm going to do over the next few weeks is come up with examples and explain the node trees for them. At first glance, my node tree may look like a gigantic, scary bowl of spaghetti, but when you break it down, it's not all that complex. In order to get all of those cubes, I made an isosphere and put the cubes around it as a particle system. Then I used the convert button on the modifiers tab and deleted the isosphere. That may be the method that I use to make my ball of cubes, but I'm going to do my node tree using this cube of cubes. One can see that animation at the end of this video. And I have to make a new node tree. Mash that new button, and I'm going to go to T and make sure that my animation nodes is not set on always. I just want to do it for when frame change happens. So in order to handle all of those cubes, what I'm going to need is a subprogram, and that's down here, loop. Then to iterate it, or to invoke it, I need invoke. Control A to search, invoke subprogram. This one's called my loop, so I'm just going to change this to my loop. Now I want to get my objects from group, so I will add object from group. Change that to the only group that's in this. And iterations is not what I needed, unfortunately, so we'll delete that. We want a new iterator, and it needs to be object list. Oosh. Then I'll plug my objects into the object list. That'll feed the object list from my group into the invoke subprogram, which will go right to this loop. The next thing I want is an object transform output. So I'll add object transform output. In this case, we're going to start with just the Z rotation of it. And we'll bring our objects over to the object here. So right now it's feeding the objects from the group to the object list in the invoke subprogram to here, to there, to the output. So currently each and every one of the objects that gets fed through this whole thing here, they all act pretty much the same. But what I want them to do is change, and there's nothing happening yet. So what I want to do is add a time info, which if I can't find it, I use Control A and just do time info, and that has a frame output, and we're just going to put that right on the rotation. And it's going to add a combine Euler. Difficult for me to say Euler because I always thought it was Euler. Since I was feeding the Z, I actually want this plugged into Z. I'm not going to use degrees because I didn't use degrees on my other example. So now this whole thing is rotating incorrectly. And I know exactly why. Because every one of these in my group here every one of those suckers needs to be aligned to geometry. Okay, so now that's better. Anyway, so it's because the origin was still in the center from when I had it as a matrix before, but now you can see all of my cubes are rotating together, but every single one of them is rotating. If I were to change it to use degrees instead of radians and hit go, whoops, Alt-A, Alt-A, you can see they're all doing what they're supposed to do. But I want them to rotate at different speeds. So I'll stop that right there. And what I'm going to do is add, under number, we'll go to randomize. Now, the index is whichever cube it is that you're using. So the first cube would be 0. The next one would be 1, all the way up to, I did 5 by 5, so it's probably 125 cubes there. So I'm going to put that to seed, and that'll make a new random number for each cube. And I want it to rotate at a random speed for each cube, and some of them backwards. So on my other example, I did 0.07, oopsie, 0.07 negative, and the max was 0.05. Then I added a math node and set it on multiply, and put my frame through that. So whatever the frame is multiplied by whatever each random number is for each one, and it'll rotate at a random speed or direction based on the random number that was generated here. It's moving too slow because I'm using degrees, and this was actually set up for radians. So if I go now, see how they're all moving in totally different speeds, and some of them in different directions. Now in my other node tree, I also had a wiggle on it so that it would rotate irregularly. So what I'm going to do now is add a number wiggle, and I want the index to go into the seed, so we get a different seed for each one. And I had added an add node in here. So we'll do another number math and do add. And we're going to put this guy in here. And, oopsie. And this right here is my wiggle. So we're getting quite a bit of rotation. That isn't what it looked like on my other one, and that's because my wiggle node isn't all set up for what it was on the other. I had the amplitude only at 0.05 or 0.5, and my evolution was also fed by the time info. The evolution progresses the value through the wiggle, basically. So there you can see wiggling and rotation. It's complicated the way we want it to be. Now I had so I had that all set up just like that, and that handled the rotation. In order to add scaling, we'll check these boxes. And I did pretty much the exact same things on scaling that I did on the other one, so on the rotation. So if I feed this right into scale, I get something that I really didn't intend to get. I want a combine vector. So I'm going to add vector, combine. Then, if I run my frame into these, you'll see a mess of stuff. It's because it's gigantic. And I had run into the same problem when I made my other one. So what I had to do is do a bunch of math to bring it down. And what I did there was I wanted it to be the smallest at frame 100. So I added a math, subtract 100, and then added it to frame. So it would shrink as it got to 100. Then, of course, I fed all these into that. This way, at 100, it'd be the smallest that it could possibly be. And it is huge. Look at that. So it was showing it humongous. Now, before I fed it in there, in order to correct that humongousness, I divided it by 1500. So I'll add another math. Divide. Boosh. Mm-hmm. Yeah. Seems like that might be a little bit too much. We'll go with one, or go with 500. There. Okay, even 500 is a little bit too much. So in this case, and it probably has to do with me not applying my scale when I combined all of those. So you got to be real careful about that. But there we've got a tolerable size difference. So it starts the way it is. Then they all shrink down to nothing as we approach to frame 100, which is looking pretty good. But I also had added a wiggle to that as well. So here I added another add node, math. We'll actually run these guys into this instead. And this was an add node. And I'm just going to copy this wiggle. Duplicate, bring it down, put it on this add node. And I'll do the same thing I did here. Put the seed here and put the evolution so it would progress. And now we've got some pulsation. And that was the effect that I ended up at the beginning of the video, just like that. If I want my things to rotate slower or shrink slower, then I can change all of that with math. So really, almost everything is controlled either by the index or the frame info and which object it is. The rest of all of this stuff is just adjustments to how much rotation and how much scaling is getting done. Please like and subscribe so you don't miss any of the future magic, and check out my ebook on procedural texture. Also, if you do buy my ebook, please leave a favorable review if you feel so inclined. You get extra credit for watching all the way to the end. Have a wonderful day.